Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 246. Please turn to it. Page number 246, and today is our lesson number 363. These problems that you see there on page number 246 are the exact same problems that appeared in the first edition of the revised GRE. We have already solved every single math problem from this book. If you're interested in watching the original solution, you will find the original solution on day number 160. Let's get going. Part D is what we're going to do here. The penultimate part, the second to the last part. D says f of x equals root of x plus 2. Now listen, before we worry about root of x plus 2, let us begin with something simple. Let's ask ourselves what happens if f of x equals just root of x. For example, if somebody asks us how much is root of 9, what is this question asking? If somebody were to ask us to articulate this thing in English language, what is this question asking? This is asking us what is that number which when multiplied by itself gives us 9. And of course we know that the answer to this question is not actually an answer. There are actually two answers to this question. There are two correct answers to this question. So technically speaking, this should have been formed in a plural form. This should have been presented in a plural form. This should have been constructed, this question should have been composed in a plural form. It should have said, what are those numbers which when multiplied by themselves give us 9? Because we know positive 3 times a positive 3 gives us 9, and we also know that negative 3 times a negative 3 gives us 9. So the square root of 9 actually is equal to positive 3 and negative 3. Now let's make it a little more interesting, okay? New question. The new question is this one. Square root of negative 9. So again the question is, what is that number which when multiplied by itself gives us negative 9? What is that number which when multiplied by itself gives us negative 9? Let's think about it for a second. A number, any number at all, other than the 0 that is, any number in the world at all has to be either a positive number or a negative number. And since we are multiplying the number by itself, so if the number is positive, you multiply the number by itself, you get positive times positive, the product is going to be positive. If the number that you have in mind is negative number, then a negative number multiplied by itself again will result in a negative times negative, product will again be positive. In other words, it is impossible to take a square root of a negative number. It is impossible to take square root of a negative number. We can't take a square root of a negative number. It doesn't exist. Answer to this question. What is that number? The question was, what is that number which when multiplied by itself gives us negative 9? The answer is no such number, no such quantity exists. No such quantity exists. Do you understand? So we cannot have a square root under, we cannot have a negative quantity under the square root sign. Let's make a note of it. No such number exists. Let's make a note of it. We cannot have a negative quantity under the square root sign. Under the square root sign. Now, let's take a look at what they're telling us, which is not x, but it is x plus 2. So here, this quantity x plus 2, here, this quantity x plus 2, the quantity x plus 2 cannot be negative. It cannot be negative because we can't take a square root of a negative quantity. X plus 2 cannot be negative quantity. Now the next question is, when is x plus 2 going to be a negative quantity? The answer is x plus 2 will be negative if x happens to be less than negative 2. In other words, if we have x plus 2, if x happens to be negative 3 plus positive 2 will become negative. X cannot be less than negative 2. Another way of saying the same thing is that here we say x is not allowed to be less than negative 2. This sentence that we just wrote here, x is not allowed to be less than negative 2, how do mathematicians say the same sentence? We have to be able to express this sentence in the language of mathematicians. This is the English language, this is not math. This is not the language of mathematics. In the language of mathematics, the values that x is allowed to take is called domain. The values that x is allowed to take is called domain. Where can we write that down? Values that x is allowed to take is called the domain of the function. Is called the domain of the function. Here, x is not allowed to be less than negative 2. In the language of mathematics, we simply say the domain is set of all real numbers, such that x is greater than or equal to negative 2. Even this part is a bit too verbose. Mathematicians do not like to be verbose. Even this part is too verbose. So they will simply write like this. In the mathematical textbook, they will simply say domain is x is greater than or equal to negative 2. This is it. This is all they will say here. They will not be so verbose. But this, what this part says is that it says domain, when you express like this and nothing else, what it says is that domain is, in other words, the only condition is that x has to be greater than or equal to negative 2. No other conditions. Another way we say the same thing is, domain here is set of all real numbers. X can be whatever the hell it wants to be. That's what it means. When you say set of all real numbers, in the English language simply means x can be whatever the hell it wants to be, except as long as such that, or as long as it is more than negative 2. That's it, we are done. The last thing we have to do is plot the bloody thing. Once we plot it, we figure out the intercept, we figure out the vertex, and we are done. Let's do it, shall we? I need the room, obviously, so we're going to have to erase everything. Just give me 1 second. Very quickly, let's get them out of the way. We just used two words here, verbose and penultimate. And I want to quickly point out when we learned these words in the event that you're interested in improving your vocabulary. And we have done this thing many times. That is, I've gone over this word many a times. Penultimate is something that we learned in on day number, oh boy, when you look for something in a hurry, day number 11. Just type in vocabulary words, day 11, and you will find it. And verbose is something that we learned. What's the noun of verbose? The noun of verbose is verbosity. verbose. Where did we learn it? Day number 16. You must also work on your vocabulary at the same time while you're trying to improve your math skill. Because of course you want a decent score in the whole exam, not just the math part. Anyway, let's talk about what the graph looks like of this function, shall we? Again, to start out with, we'll have something simple, which is fx is root of x. Let's see what the graph of this thing looks like. So here's our values of y, here's the values of x. When x is equal to 0, y is 0. When x is equal to 0, y is 0. When x is 0, y is 0. When x is 1, y is going to be f of x equals to y is going to be 1. So here we have 1, 2, 3, 4, 1, 2, 1 and 2. So when x is equal to 1, y is 1. So we get somewhere here. When x is equal to 4, here, y is equal to square root of x, and square root of 4 is just 2. So when x is equal to 4, y is going to be 2. 1, 2, 3, 4, and y is going to be 2. Let's connect these points, see what we get here. What we get here is a parabola. What we get here is a parabola, but only half of it. The bottom half does not exist. The bottom half does not exist. Now, let's introduce the complication that we have, which is we are not given y is equal to root of x. What we are given here is that y is equal to root of x plus 2. We are told y is equal to root of x plus 2. What sort of graph will this be? What will be the shape of this graph? Let's plot it, shall we? Of course, if you have watched the last few videos where we have done when we have talked about shifting the graph left and right and up and down for the last few days, for those of you who've been watching this those last few videos, you know right away what would happen here. Let's find out, shall we? So before x was, listen carefully, before y was 0, when x was 0. Now, when is y going to be 0? Y is going to be 0 when x is going to be, so this is the before part. This was the before part, this is the after. After is this part right here. Now, when is y going to be 0? Before y was 0 when x was 0. Now y is going to be 0 when this quantity is 0, which means when x is equal to negative 2. Negative 2 plus a 2 will give us root of 0, and root of 0 is 0. So here y is going to be 0 when x is negative 2. Y is going to be 0 when x is negative 2. So the story begins from this point right here. Are you able to tell right away what's going to happen? What's going to happen is that we're going to have the same graph as before, except we're going to pick it up and we're going to shift it to the left by 2 units. As you can see clearly, the story does not begin here. The story does not begin at the origin. The story begins here, 2 units to the left. So one more time. Before y was 1 when x was 1. Before y was 1 when x was 1. Now let's find out when is y 1 at what value of x. So right here our function is y is equal to root of x plus 2. If x happens to be negative 1, negative 1 and a positive 2, square root of a negative 1 and a positive 2, negative 1 and a positive 1 is 1. And y is going to be 1, in other words, y is going to be 1 when x is negative 1. Y is going to be 1 when x is negative 1. You see, instead of a positive 1, it is negative 1. It's been shifted to the left by 2 units. Y is not 1. Y is not 1 when x is 1. Y is going to be 1 when x is negative 1. Instead of being here, it's been shifted by 2 units. y is going to be 1 when x is negative 1. Similarly, before y was 2 when x was 4. Now y is going to be 2 when x is only 2. Because it's been shifted to the left by 2 units. As we can clearly see here, if x is equal to 2, we get 2 plus 2, which is square root of 4, and that's y, and that's going to equal 2. The square root of 4 equals 2. So when x is equal to 2, y is equal to 2 also. So when x is equal to 2, when x is equal to 2, y is equal to 2. Before x was equal to 2, before y was equal to 2, when x was equal to 4. Now, instead of x being 4, instead of x having to be 4, x is only 2. When x is equal to 2, y is equal to 2, because 2 plus 2 will give the square root of 4, which is 2, as you can see here. So it's the exact same graph, it's just been shifted to the left by 2 units. Let's put it together, shall we? Let's put it in a different color, let me make it darker. It's the exact same graph as before. You just pick it up and you shift it to the left. That's what this plus 2 tells us. I'm going to erase all of this thing now. Perhaps I can write it here. This plus 2 right here, let's put it here. Y is equal to root of x plus 2. This plus 2 tells us the graph has been shifted to the what? Not to the right, but to the left by 2 units. As I always remind you, the shift along the x-axis is counterintuitive. Your intuition might tell you that since this is plus 2, should be shifted to the right. No, as you can clearly see, it's been shifted to the left. The very last thing that is left here for us to do is to figure out the intercepts and the vertex. Let's do it, shall we? Vertex is very straightforward. Vertex is right here. This is where the story begins. The vertex is right here. The coordinates of vertex are simply -2 and 0. -2 and 0. Let me rewrite it. -2 and 0, which also happens to be same as the x-intercept. X-intercept is same as here. The graph cuts the x-axis at the same place. So the x-intercept and the vertex are the same. The coordinates of vertex are -2 and 0. The very last thing that that is left for us to do is to figure out where the graph cuts the y-axis, right here. The y-intercept. Well, the y-intercept is where the value of x is 0, because that's along the y. It's called the y-intercept because that's where it cuts the y-axis. The place where it cuts y-axis, the x-coordinate is 0. This is our y-intercept. And because it's y-intercept, the reason it's called y-intercept is because the x-coordinate is 0. Well, what's the y-coordinate? Let's find out, shall we? Well, that's very easy. We just put in 0 in here for x. Y is equal to x plus 2. Y is equal to x plus 2. We put in 0 for x, and we find out that y is equal to root of 2. So the y-intercept is root of 2, which we know is approximately 1.4. Approximately 1.4. So that's it, we are done. We have our y-intercept. We know that graph cuts the y-axis at around 1.4, root 2 to be precise. The x-intercept is same as the vertex, which is -2 and 0. It is half a parabola. The bottom half does not exist. It's a half a parabola opening along the x-axis, not along the y-axis, opening to the right along the x-axis. This is it. Tomorrow we'll do the very last one that is there that you see there, part E. But these were tricky. These 5 questions that they give us are a little tricky, and they just want to make sure they give us this problem to make sure that you understand all of these concepts. These are very basic concepts that you must know, that you must have at your fingertips if you're going to sit for the revised GRE. These things did not exist in the old GRE. These are all new stuff that wasn't there. You didn't have to worry about parabolas in the old GRE. I'll see you tomorrow, okay? Bye now.